So here's something really cool. For a while I've been investigating what happens if you model the universe as a superfluid. And I'm excited to share that I found the math that puts all of the pieces together in such a clean, satisfying way that we have something big to talk about. I call it the substrate framework. I'm an engineering fellow at Posit. We make open source software for data science. So I'm a novice when it comes to physics, but good at debugging. This is a side project that started in June last year when I saw one of the first Vera Rubin images on a 5K monitor. This image led to the realization that dark matter has to be dark material, vortices and orbital systems spinning at close to the speed of light. Eventually, this framework emerged that answers big open questions intuitively and with equations that match from the microscopic to the galactic. These 5 visionary works joined to make the bridge equation. Volovik's work is the core of the superfluid model. Bush-Oza-Coudet showed that frictionless fluids work a lot like quantum dynamics. Semyonov bridged fluid dynamics to quantum mechanics. And Curie found the superfluid nature of dark matter. All combined with the broad base of research on vortices, modons, dispersive shock waves turned into the substrate framework. Then it started explaining things. It bridges the domains covered by general relativity and quantum field theory without uncertainty or warping of space and time. And along the way, it just makes more sense. It explains those distant galaxies that don't fit. It offers a more accurate model for the observations of dark energy density, energy clumpiness, and expansion. And it sheds new light on basically everything: geology, fire, water, cells, DNA, perception, including the mechanism behind chi. And if you make it to the end, you'll learn a lot more about how the brain works. So, if you're curious, let's start at the beginning. Rather than a big bang, I've taken to calling it our big bubble. It's one of many, so I use B0 to be precise. It formed when its internal pressure built up enough, like a steam bubble in a pot of water. Everything we have ever observed is the interior of this bubble and the wall it carved when it formed. And we know it's not the first one because the previous bubbles left a moraine that our bubble passed through, like a wave washing over a sandbar. It will eventually recede, and when it does, the black holes will build up pressure until they pop in a cascading way for B+1. The framework supposes that there are at least 2 particles in the bubble. One is tiny, I call it DC1, dark carbon, lighter than the electron by a factor of millions. The other is much larger, DAG, dark silver, 1,000 times heavier than DC1 at least. The smaller particles, lighter, vastly more numerous, form a superfluid that spins with angular momentum from the creation event and fills the universe. There's nothing that removes this material from space or the inside of the atom. The big particles, DAG, form the core of larger orbital systems that serve as anchors, pinning the lattice and holding the layers taut. The lattice cell size, about 100 micrometers, it's the width of a human hair, falls out of 3 measured numbers: the speed of light, Planck's constant, the dark matter density. That's the key part of the bridge equation. Before I show you how atoms form in the substrate, let's see what all fluids do with lots of shear energy between boundaries. Look at the bands of Jupiter, eastward and westward jets, separated by turbulent shear zones. Each band is a co-rotating flow. Each boundary between them is a counter-rotating layer where the 2 fluids grind against each other. And when wind blows over water or 2 cloud layers move at different speeds, the shear becomes unstable and rolls up into vortices. This is a microscope image of vortices in a superconductor near its threshold when individual quanta of magnetic flux break through the superfluid, forming this hexagonal lattice. Notice the scale is 100 micrometers, the lattice cell size. That's a happy coincidence. Now, imagine the same pattern, but in the dark matter superfluid that fills space. It's the same physics at a different scale. Here's one key scale invariant pattern you'll see again and again. Every boundary between co-rotating regions spontaneously generates a counter-rotating layer. So the same spin regions are in blue and the counter-spinning boundaries are in red. And the number of boundary layers between two regions, odd or even, determines whether the system behaves as a charged particle, a fermion, or a neutral particle, a boson. Fermions include protons and electrons that form matter. Bosons can move freely like photons. This model cleanly explains spin statistics, the Pauli exclusion principle, and how matter and radiation emerge from the substrate. In the substrate, due to the rotation speed of the superfluid, the elasticity, the stiffness of the lattice, a large enough disturbance becomes a topological defect. Or in other words, a big enough storm becomes a permanent feature. It could be a vortex core or a knot formed by three vortices that lock into place. On the left is the lattice with the 100 micrometer scale. It's the perturbation envelope or the wake distance of the electron. In the middle, zoom in 1 billion times. Here's one DC1 vortex in the lattice, a quantum. These are the vortices in between boundaries. On the right, zoom in 100,000 times. You'll see the 3 interlocked channels in a knot to form a proton. Here's the electron in the substrate. It's a storm with a pilot wave, not a dimensionless point. It breathes. It throws off a rippling wake and has 2 counter-spinning layers, which explains the weird spin properties where it takes 720 degrees of rotation to return to its original state. Now see how the electron's pilot wave ripples around the orbit, and when the circumference is the exact multiple of the wavelength, it forms a standing wave. The substrate locks into a self-reinforcing pattern, a co-rotating flow in the orbital channel with counter-rotating eddies at the channel edges. The electron is surfing the groove it carved in the medium. The wavelength ensures only certain orbits work. That's quantization with no uncertainty. It's just a vibrating object in a wave-supporting medium with memory orbiting the nucleus. And the quantum potential, the mysterious Q, is the very real reaction force from those 2 counter-rotating eddies at the channel edges. When a photon hits a hydrogen atom, it can change orbital states in various ways. It can inflate to the next quantum, or it can fold. And when it folds, it either creates a radial node or a nodal plane. And this is a fundamental substrate behavior. Compare those nodes to the polar jets, a feature of planets, stars, and galaxies. All are passing along excess angular momentum to the next layer in the substrate. As an orbital system tilts in the lattice, the jets increase like a water skier leaning into the turn. The jet flow causes a stabilizing pull from above and below as the lattice sheets redistribute that polar energy. And the spinning mass, with its angular momentum, weaves into the orbital system in the plane of the lattice. So the 2 effects combine to form this springing mattress that works at all scales and distances to move the photon modons through a least energy path. And the vortex lines in the superfluid act like wires to hold it together and at the same time hide it from observation. It perfectly mimics a vacuum. And the speed of light c is the property of the substrate, and it's computed from the 3 measurements set by the medium, the way the speed of sound is set by the air. These 3 motifs appear again and again. You'll find 120 degree angles when organized rotation shares a boundary in three ways. The substrate picks 120 degrees, whether it's between tectonic plates, cooling basalt, fairy circles, the junctions of the endoplasmic reticulum tubes, or the stacked plates of the chloroplast. And sharper than expected boundaries between layers. The energetic, counter-rotating boundary layers are more rigid and narrow than you'd expect from diffusion. Watch for the 660 kilometer mantle discontinuity, the Gulf Stream's edge, and the heliosphere. Thin stacked sheets with thin counter-rotating films between them and silicon materials, the stratified mantle, and organization of biological membranes. Here's how a photon modon is created. In an atom, when an electron drops from a higher orbit to a lower one, the standing wave between those two oppositional layers with locked vortex lines have that energy that has to go somewhere. When the boundary collapses, those two layers fold into a modon, two oppositional vortices with an ejection and driving force. The oppositional rotation pulls it along in the lattice, each one in a velocity field of the other. And when the modon hits a boundary in the lattice, the two cores just swap spins, the dipole continues, the same energy, same speed, opposite-handedness, nothing's lost. The modon is massless because its two halves carry equal and opposite angular momentum, so the net is zero. It travels at exactly c because that's set by the medium, the opposite spinning vortices at like 3/4 c. And metals conduct electricity because they're packed closely enough that their outer orbitals merge, creating a merged channel. And the smoother the merged channel, the more easily the electrons can move and the better it conducts. On the other hand, for metals to superconduct, they need a defect to create the disturbance that puts the two electrons into an opposite breathing phase. And when this happens, they form a superconducting pair with the counter-spinning center vortex. This shows the opposite spinning layers and shows how a modon spontaneously forms from a different topology. It just needs balanced counter-spinning layers. So the counter-rotating boundary layers that wrap every particle do three things. They push back against the internal flow, that's the quantum potential. They eject the photon modons, and they leak. A tiny fraction of the DC1 particles, roughly 1 in a quadrillion per interaction time, transits each counter-rotating boundary, carrying momentum from one massive system to another. That trickle is gravity. And this is important. It's the same substrate boundary layer, the same math. Gravity's weakness, the leak fraction, showing near perfect barriers, also explains why atoms are stable. And now we understand that general relativity, gravitational redshift, light deflection, and GPS corrections all emerge as properties of fluid dynamics. It's clear that time is not dilated and space is not warped. But who knows, maybe warp drive is on the table. And wormholes are not a thing, as entanglement has been unentangled by long distance, topologically protected vortex lines. It's the same stiffness that gives you a billion times scale up from an electron to its wake, connects the split particle even at great distances. So measuring it on one side is like cutting a high tension wire. It springs back faster than the speed of light, affecting the measurement on the other side. In the framework, dark energy density is modeled by two components. Law of self-tuning is the baseline that predicts how density changes during expansion. The second component is the density of the moraine crust. I modeled this both as a dispersive shockwave energy envelope, then as a spline. The observational data is sparse and the error bars, so the fit curve's not precise, but still, in each one the shape emerged. And it's the shape predicted by the framework when our expanding bubble wall hit the moraine, a leading soliton upstream, a recovery zone, and then a chirp wave train downstream toward low redshift. This may be our bubble's fingerprint. Fire breaks apart molecules, but the lattice cells are not strained except in the most dramatic explosions. So photon modons are shed to release the stored up energy. The lattice vibrates as pressure and shear waves. So the bridge equation says that the maximum shear wave velocity of the substrate is 9 kilometers per second. And here's the detonation speed, clustering up just below and then a little above that speed. Earth shear waves would also be constrained by that same number and peak at just over 7 kilometers per second. Here are these two large low shear velocity provinces that shape the planet's geology, Jason and Tuzo, right where the substrate framework expects, opposite spinning massive modons. Here's the 660 kilometer line, a sharper boundary than you'd expect, that rejects the shear angles but allows the occasional punch through, all substrate boundary layer phenomena. Here are the supercontinent formations like Pangaea that form an oscillation in the substrate. In 1867, Kelvin proposed stable knots of circulation, the vortex atom, and Maxwell built his theory on molecular vortices, but abandoned it as scaffolding. They could not explain inertia or why the electron did not just collapse into the nucleus. But they were missing the concepts of a superfluid, the rotational energy built into the substrate. They had no model for the topological protection due to all that energy. So to understand magnetism, it's no surprise that the same math that models atoms and gravity also describes the magnetic field as an organized DC1 substrate flow leaking through aligned atomic boundaries. It's the physical flow in the substrate that you can feel. And now let's turn to a physical flow you can see. Science today is puzzled by the fact that clouds do not have enough energy to cause lightning. That energy is the substrate peeking out from behind the veil when electrons are pushed past the speed limit. Photons are ejected as gamma rays, and a lightning bolt forms as a cascade of vortices in the substrate. The substrate stores enormous energy. One DC1 vortex core has 1,000,000 times more energy than a typical atom. The substrate is a silent organizer for heat at all of these different scales. Okay, in carbon, a benzene ring forms when 6 carbon atoms find a lower energy state by sharing electrons. In the substrate, this is a toroidal vortex for all the electrons in the opposite spinning layers above and below. And when you put more than one benzene ring together, it creates an aromatic stack, multiple toroidal vortices, a columnar pattern in the substrate. And one example is the codon, 3 aromatic bases, where each opposite base pair aligns. The 2 toroidal vortices of the purine fit in with the 1 in the pyrimidine. This gives you the A matches with T and G matches with C pairings. When 3 bases are stacked into a codon, all 3 waveforms combine through a chain and match with its anticodon. the matching of the stack with its anti-stack, the substrate pulling in specific opposites to close the gap in the substrate coherence. And DNA is just a long stack of aromatic stacks. It has the modon topology. And here's the clear regulatory chain from the mediator that selects the transcription targets connected up the polar charge transport channel in the DNA, latching on to a specific matching stamp to start the transcription. It all forms a large energy feedback loop, building up from the polar jet signal for the next transcription, the releasing of that energy back into the cell, the canonical topology. And to show a little more concrete evidence from the chemistry perspective, the microtubule, a closed cylinder, should have 14 protofilaments from the chemistry, and yet it has only 13. And no one understands why bDNA's pitch angle is 10.5. Both of these are predicted from the bridge equation based on the substrate boundary effects. Here's the photon modon received by the chlorophyll and is separated into two opposite spinning layers, a proton gradient above and a reduced electron carrier half below. And the endoplasmic reticulum is the largest single membrane structure, a continuous tube network with these three-way wide junctions that slide continuously with the 120-degree angles, the substrate-mediated control network of the cell. And here's the nucleus along with the mitochondrion, both double-wrapped layers for extra coherence. And the mitochondrion is an opposite spinning layer to balance the cell's own energy. And the myelin sheath around nerve fibers has even more layers for higher levels of coherence. The cilia is the exterior-facing polar jet and sensor in the substrate. It has three sensing channels, electromagnetic, mechanical, and chemical, all driven by the substrate. And the photoreceptors are counter-rotating wrap filled to catch a photon modon, then step down the signal cascade, the energy rungs formed by the substrate standing waves. After that, it joins up with a mechanism similar to cilia, acting as a substrate antenna. And the nose has a different step down, then works the same way, just like with enzymes. The aromatic stack substrate signature supports the diversity of smells and the accuracy of recognition. You have like a superfluid binding glue that matches with this opposite attract stamp. And here's the cilium architecture at body scale, sensing the outside, multidimensional. It's the boundary layer for the body's coherence layer, which is surrounded by an exterior layer in the substrate, an opposite mirror to what's inside. So this is just like magnetism. It's a force in the substrate you can feel. Here's the neuron, a polar jet that spans the length of the body. It has all of these wraps, substrate counterspinning layers to hold the energy and provide a coherent channel for that polar jet signal. And the synapse matches the polar jet from one neuron to the inward antenna fan, the same stamp matching to explain this subtle interface. Scaling this up, the brain emerges as a differential prediction and control engine running on a multi-scale substrate coherence stack. Its main primitives are variable length cortical columns, each a substrate standing wave basis set with polar jet axons and inward fans to send and receive signals based on precise stamp matches. And they're organized into these topographic maps parameterized by the continuous sensory and motor networks and feedback loops to keep it all trained. And there are two hemispheres, right? Balanced substrate energy, just like two giant nested modons. And the yin-yang balance between the two halves is structural. From this perspective, the flow state emerges as a flexible, creative, connected mind. Here's the high-level view of the bridge equation. Modons require a minimum energy to form based on their speed, the density, and mutual friction of the fluid they are in. Planck's constant and the speed of light determine the minimum energy required to form a photon modon in the substrate. We can get the mutual friction from the Weinberg angle measured in particle colliders, which describes how electromagnetism mixes with atoms. So using the modons equation with these values gives us everything. The lattice cell size, the mass energy of the DC1 vortex core, and then all the fluid dynamics predictions based on this fluid. So even with the very early state of this investigation, I hope you can see how it all folds together. Nested, balanced substrate layers. I've shown you the same topology, the feedback loops using substrate energy, and the hidden counter-rotating layer, the polar jet for signaling. The introduction, the visual narrative, and bridge equation experiments page on lightfluid.org give the clearest picture. The deeper dives need a lot of editing, and for clarity and quality control, we're really only scratching the surface of what the substrate framework will uncover. So please let me know what you think and subscribe for updates. Thanks for watching.